Should I use this? Okay, I'll just talk here. Do I go through the slides? Okay, that's me. Anyway, well, I'll talk while I'm doing this. You don't have to convince us too much, I don't think. So I'm Jacob. I'm from Interstellar Lab, like Andrew said. So first I want to thank Grant Farms and UND for having us here. Super honored to be here. Went on the tour today. Everything was amazing. The campus looks great. It's been a really great time. So real quick about Interstellar Lab. We were founded in 2018 by Barbara Belvisi. We are a biotech company that we develop and manufacture controlled environment agriculture systems to essentially perform plant research, both terrestrially and in space. Barbara's kind of vision is to preserve life on Earth and expand it into space. And then I'll give a quick introduction about myself. So I went to Penn State, sorry to UND. Went to Penn State, studied chemical engineering, and then I got into a career at a company called Nanorax that sends a lot of research to the space station. So my job was to help researchers and commercial companies send things to the ISS. I've sent over 100 experiments to the space station. Those are Hilton cookies. I've sent wine bottles. I've done fiber optic experiments. I've done biology experiments and fluid physics. I've done everything. And so I really have an understanding of the ISS program. And I think that Interstellar Lab hired me to be the lead of our space program to kind of take everything that we're doing terrestrially and move that into space, which I will get into. So here's our vision. Right now, we're on Earth here. Of course, in low Earth orbit, we're going to start developing our systems and put them on the ISS, other commercial space stations. In 2027, we have a lunar mission, well, the first of all our lunar missions planned, which will be a small controlled environment system on the moon. We're growing a rose. I'll get into that a little bit later. And then from there, with the Artemis missions going on, we will start to develop these lunar habitats that we're working on, lunar and Martian habitats that will be bioregenerative life support systems, focusing on growing plants, and also, controlling the environments for the crew members for food purposes. I'm going to start with our terrestrial kind of model. So what you see here is our biopod on the right. I know some of you have been to our facility in Paris and have seen that. Right now, what it does, it's a controlled environment agriculture system. We control all of the environmental parameters in that system: temperature, humidity, pressure, atmospheric composition, and we are essentially growing plants and manufacturing plants and controlling them in a way to produce very specific compounds. So we have an agreement with L'Oreal right now. We're growing a flower in there that, if we increase the temperature a little bit, maybe this flower produces this fragrant compound more. So that's what we're looking at right now. That's what we would love to bring to UND at some point, or Grand Farms, somewhere in North Dakota in general. Right now, it's mostly based out of Paris. That's where our prototype is. We're building our second facility, or our second model of this soon. So this one pictured here is about 200 square feet. Our production module will be 500 square feet. And then these phytotrons on the left, well, maybe you're right, I don't know, are basically the precursor to moving into that system. So we'll do small experiments there and then move them into the larger system. That's on the terrestrial side. Our partners right now and people we want to work with are universities to do research with commercial companies like L'Oreal on the cosmetic side, on the pharmaceutical side. And then moving into the space applications. So I'll start with kind of low Earth orbit, and as we move out further. Right now, the system of space is the ISS is coming down soon. That's NASA's plan, and their plan is to push the commercialization to these commercial space stations. So groups like Voyager, Blue Origin, VAST, and Axiom, and there's a few other smaller ones building uncrewed free flyers, are building these large commercial space stations. We want to essentially do twofold our projects in these stations. So one of those is plant research. So we plan to build a what's called a mid-deck locker equivalent size experiment, or research facility, really. It's about the size of kind of like this chair, where we would be doing growth experiments on the ISS first and then putting them on these commercial space stations. Right now on the ISS, the current state of this research is with the veggie platform and with the advanced plant habitat. The veggie is great. We've grown peppers in space. I believe we've grown tomatoes and some other things, but there's really no, it's hard to do science with it because it's open to the environment. You really don't have any controls. On the APH side, there's a ton of sensors and things, but it's small and it gets really into fundamental biology. So we kind of want to strike this middle ground with doing holistic crop research. Again, looking at customers like L'Oreal, other cosmetic groups, food and bev, and pharmaceuticals to see how can we grow plants in space to produce things that would be beneficial to us on Earth and just doing research in general. And then also on the commercial space station side, we are working on building food production equipment for these commercial crew members. This is just everything I just said. So our nucleus system, the Nutritional Closed Loop Eco Unit System, I didn't come up with the name, but it's a great acronym. So this system was put through the NASA Deep Space Food Challenge that recently went on in August of this year. We were named the winners of this challenge. Came with a great prize from NASA. It was a 3-year kind of hardware development challenge where we were building a bioregenerative life support system. So Nucleus is designed to grow food. In the 3 modules there are basically the brain of the system, the irrigation system, all kinds of controls, and then the other 6 modules on the outside are where we're growing the crops in them. We call them our biocorks. The top 4 are for veggies, sprouts, microgreens, things like that. We grew radishes, we grew broccoli, we grew onions, amaranth, fenugreek, and then the bottom 2 are, one of them is for fungi, where we were growing oyster mushrooms, and the other one is for black soldier flies. As part of the challenge, this was at OSU also. So Ohio State University had these simunauts, is what they were called, very similar to the crew that was in the lunar habitat. These students were subject to doing these crazy experiments for space knowledge, and so they had to eat these the black soldier flies. They had to eat the everything out of this that we were developing for them. So over a month and a half, we grew 10 kilograms of food. Won us a challenge, and my goal is to work with these commercial space stations to put these systems in there and feed their crew members. Right now, it's expensive to send things to space, like $20,000 to $40,000 per kilogram to launch things. There's about 4,000 kilograms of food that's sent to the ISS each year to feed the crew members. So if we can cover 25 to 50% of the crew's needs, then we think that we're helping these commercial space stations save a lot of money. I keep talking before I move to the next slide, but these are the goals of the Deep Space Food Challenge that we accomplished. And then I have a short video here, basically just going through the system. We're very proud of this. It was our first big win as a company, other than the biopod, but on the space side, this was our first big win that we really care about. I think this research kind of ties into what Space Ag is about and trying to do with the things that we're learning in space. We can put those and use that back on Earth. So since humans have been going to space and doing research, we've been studying how seeds grow, how plants grow, how everything about plants. It's been a big piece of, I think, space travel, and we really want to continue that research on a larger scale level. So we know a lot about fundamental biology of how plants respond to gravity and how they respond to light and things like that. We want to take it on a next level and figure out how they respond to, or how the crop itself, how can we maximize crop production? So maybe we learn something in microgravity that helps us, I don't know, grow beets. Beets were thrown around a lot today on my tour, so maybe we can grow beets better here in North Dakota if we learn something about them in microgravity. I will also say, I was going to say this earlier, I am not a botanist or an agriculture person by any means. I studied chemical engineering. Everything I touch seems to die, so I'll stay away from these flowers. But I know a lot about space, and I know how to get things to space, so that's why I'm here. So I'll keep going. So that's in low Earth orbit. What we're trying to do, again, is plant research and food production. The plant research, again, is to help life back here on Earth Can we manufacture something in space through plants? Can we learn something about crops in space that can help us on Earth? And then the food production side is how can we feed people on Leo, on the moon, on Mars. The further we get away from space, or from Earth, of course, is the harder it is going to be and more expensive to feed people. Not just expensive, but the quality of food will start to go down. So we'll have to have some way to produce food in space at some point. In Leo, it doesn't really matter. The grocery store's in our backyard. But once we get to the moon, it gets a little harder. On Mars, it's nearly impossible. We're starting with our kind of that long-term goal, which is a little difficult because right now, nobody's really paying for this. It's just the government paying for research to do these things because we want to. There's no real customer yet other than the government to figure out how to grow food on Mars. But we're starting here with lunar missions. So in 2027, we have a payload plan to go on Astrolab, who is one of the rover companies developing a lunar terrain vehicle for NASA. We are launching what's called Mission Little Prince on that. So our company has a collaboration with the Saint-Antoine-Exupéry family, which I'm going to get yelled at for mispronouncing that, but I'm not French. The Le Petit Prince is this famous book, children's book in Paris about a small astronaut. I guess he's an astronaut. He cares very much about his rose on his world. So we have a collaboration with the family and with the book to essentially we are going to grow a rose on the moon. There's research involved in this, and there's a ton of engineering involved to making this happen. But really, this is supposed to be this big STEM inspirational mission. So we are building this controlled environment system to keep this rose alive. We're going to try to keep it alive for 14 days because on that 15th day, it's lunar night, and it's going to be like negative 220 degrees on the moon. But for those 14 days during the day, we're going to keep a rose alive, and that's the whole goal with this mission. After that, we will start to develop and build the system larger, and those pods that you saw for Mars, that's what we're going to start to develop for the moon to provide habitats for future astronauts on the moon. And then that will go to Mars after that. So I think that's my last slide. Here's some of our black soldier flies. They don't bite you, and they don't sting. I don't know why they're called soldier flies. But we chose them because they eat all the dead material that we don't eat, like the roots and things from plants, and then we can eat the flies. So it's creating this circular system. That's everything I have to say. Thank you, everyone, so much. I'm very honored to be here, and looking forward to speaking with everyone.